So lesson 4 looks at determining an angle measurement from a trig ratio. So we have already done this before. That's when you do the inverse. So if given the trig ratio, can you find out what the corresponding angle is? What we're going to look at this time is, instead of just looking at those primary or those acute angles from 0 to 90 degrees, we're actually going to go all the way around the circle up to 360 degrees. So first thing that we want to do is we want to know what the sign is of the angle in a particular quadrant, whether or not it's positive or negative. So that's looking at the cast rule. And then we want to determine what the reference angle is. The reference angle is what I get when I do that sine or cos or tan inverse. Because when I take that ratio, it's only going to give me the first angle it comes up to. But we know as we go through or go around, or as we add our multiples, that we can have more than one possible answer. Always check the given domain to determine that the quadrants are relevant, because sometimes the domains will get restricted. Sometimes you'll be told that theta can only be between 0 and 180 degrees, or it has to be between 90 and 180. What we'll do in the next unit is look at domains that are less than 0 degrees or more than 360 degrees. Okay. So if we look at the first example, and I'll pull up the calculator at the same time. So it says complete the following to solve for theta when cos theta equals negative 0.5. And theta is between 0 and 360 degrees, which means my calculator needs to be in which mode? Degree mode. So you have to be in degree mode for this to work. Okay? So if I look at my cast rule, what quadrants is cosine negative? 2 and 3. So theta has to be in quadrants 2 and 3. My reference angle I will get by going cos inverse 0.5. Not negative, but positive. So cos inverse 0.5. And what do I get when I do that? 60 degrees. So my reference angle is 60 degrees. So if I was to draw that, that means I have a 60-degree reference angle in quadrant 2 and a 60-degree reference angle in quadrant 3. So in quadrant 2, what would my rotational angle be? So my rotational angle is the one from the initial arm to that point.
120 degrees.
And how did you get 120? 180 minus 60, 120 degrees. In the third quadrant, my rotational angle would be what?
180 plus 60 degrees.
Which would equal 240 degrees. So if I took my calculator now and made sure that I was in degree mode, if I type in cos 120, I get negative 0.5. If I type in cos 240, I get the same thing. If I did cos inverse of negative 0.5, my calculator would give me 120 degrees, but then I'd still have to do calculations to figure out that third quadrant. So if I do cos inverse of the absolute value, or a positive, there's my reference angle, and that reference angle is easier to use in those other three quadrants. Okay? if we look at class example number 2, it says given that sine theta squared can be written also as sine squared theta, so you'll see it written in this form more than you'll see it written this way. So you'll see it written as sine squared theta. Solve the equation sine squared theta equals 0.5 on the interval from 0 to 360 degrees. So if I have sine squared theta equals 0.5, how do I go from sine squared to sine? In other words, how do I undo the process of squaring? Square root. So then sine theta equals the square root of 0.5, but I have to consider that I can have a positive or a negative. So in which quadrants is sine positive or negative? So which quadrants is sine positive?
1 and 2.
And which one is it negative?
3 and 4.
So I have to consider all 4 quadrants, because sine could either be a positive value or a negative value. So now if I determine my reference angle, I go sine inverse the square root of 0.5, and how many degrees do I get?
30 degrees.
The square root of 0.5?
Oh, that is the square root.
Do the square root.
45 degrees.
45 degrees. And now if I was to sketch this out and get a visual, that means I have a 45-degree angle in all 4 quadrants. So in quadrant 1, my rotational angle theta is equal to the reference angle. So it would be 45 degrees. What would that rotational angle be in quadrant 2?
180 minus 45 degrees.
Which equals?
135 degrees.
And what about quadrant 3?
180 plus 45 degrees.
Which equals?
225.
And in quadrant 4?
360 minus 45 degrees.
Which equals?
315.
So theta could be any one of those 4 angles, and if I checked, sine theta would equal the square root of 0.5, or sorry, sine 45. Sine 135 is going to equal the positive or negative square root of 0.5. Sine 225, the same thing. Sine 315, the same thing. Okay? So we just work on some more examples of this nature. So what happens if we have reciprocal trig functions such as cosecant or cotangent or secant? We do not have those keys on our calculator. We cannot calculate secant, cotangent, or secant. So we have to go back to the reciprocal, to the primaries. So for example, if we have the equation cotangent equals the square root of 3, we replace cotangent with tangent, and we reciprocate the 1 over root 3. Or sorry, we reciprocate the root 3 to get 1 over root 3. And then we go through the same processes that we did before. First process, what quadrants is tan positive?
1 and 3.
1 and 3. So I know now that I'm in quadrants 1 and 3. Once I know the quadrants, second step, reference angle. So if I go tan inverse 1 divided by root 3, what do I get for an angle?
30 degrees.
30 degrees. So in quadrant 1, what would angle X equal?
30 degrees.
Okay. And in quadrant 3, what would X equal?
210 degrees.
210. And you get that by doing what?
180 plus 30.
Good. Okay, so see if you can do class example 4 on your own.
Did you do
So if we look at A, what is my reciprocal trig function to secant?
cos?
Cos. So I can rewrite this as cos x equals 1 over 1.2631. It'd be negative. And then the question, what quadrants is cos negative?
2 and 3.
2 and 3.
Did you make it an absolute value? Or did you make it? That's why.
Now when I do my reference angle, I want to do cos inverse 1 divided by 1.2631, which gives me to the nearest degree 38 degrees. So then in quadrant 2, how would I get x?
180 minus 38.
Which equals,
142.
and in quadrant 3, it would be
180 plus 38, so 218.
and I can double check this. I could type in cos 218 and see what my answer is. Make sure it matches up with cos 142. Okay, what about cosecant? What's my reciprocal to cosecant? Sine. So this becomes sine x is 1 over 2.45. It's positive, which means I'm looking at which quadrants?
1 and 2.
1 and 2. My reference angle is what?
24 degrees.
So then angle x in quadrant 1 would be,
24 degrees.
and in quadrant 2,
156.
because I would subtract. There we go. Okay, class example number 5 gets a little bit trickier. So we have cos theta equals 0. 0 is neither positive nor negative, but it still means, or because it's neither positive or negative, we need to consider all 4 quadrants. What's my next step once I have the quadrants?
Find your reference angle.
Find my reference angle. What's my reference angle? 90 degrees. So if I think about that, in quadrant 1, what would theta equal? 90 degrees. It's the same as the reference angle. What is theta in quadrant 2?
90.
And how do you get the 90?
180 minus 90.
180 minus 90. So it ends up being the same thing. What do I get in quadrant 3?
270.
270. 180 plus 90. And what about quadrant 4? 270 again, because 360 minus 90. So my 2 angles would be 90 degrees and 270 degrees. So in B, we have cosecant theta is undefined. Cosecant is a reciprocal trig function. What is it reciprocal to? Sine. So the reciprocal trig function is sine. In our experiences, when is something undefined?
When you divide by 0.
When I divide by 0. So this right here implies that cosecant theta has to be some value divided by 0. So if that's what cosecant theta has to equal, what would sine theta have to equal?
0 divided by 0.
Which would just be 0. Again, I have to consider all 4 quadrants. And now I can determine my reference angle. So sine inverse 0 equals what does it equal, Evan?
0.
0. It equals 0 degrees. So in quadrant 1, that's 0. What is it in quadrant 2? 180. What about quadrant 3? 180 again. And what about quadrant 4? 360. And because if I look at my domain restriction, theta can be between 0 and 360, and it can be equal to both those values, 0 and 360 are possibilities. Okay? This is all dealing with degrees. Now we're going to do the exact same thing, only now we're going to be in a radian measurement. We do virtually the exact same thing. The only difference is that reference angle in determining the reference angle. So for now, we'll do some where the reference angle is to the nearest 10th or 100th of a radian, and then we'll look at exact radians. So this goes through the exact same procedure. Again, you're taking the second or the inverse of the absolute value, so always a positive identity. And then this again is just how do I get my rotational angles with my reference angles, which we already did before. This one is 180 minus the rotation, so 180 in radians is pi, so this becomes pi minus the reference angle. Pi plus the reference angle, 2 pi, because one rotation is 2 pi. So we're going to jump right into class example number 6. Cos theta equals negative 0.5, and theta has to be between 0 and 2 pi. So what would be my first thing that I need to determine?
The reference angle.
Before the reference angle? Quadrants. So what quadrants am I in? 2 and 3. Now I determine my reference angle. What mode do I have to be in? Make sure you're in radian mode. And it's cos inverse 0.5. Is that working out using the R and the degree, Jessica?
Sometimes. Occasionally.
We'll try to figure out why that's not working.
I got it working, but now today it isn't.
So what do I get for my reference angle? Let's give it to me in 3 decimal places.
1.047.
Okay. So in quadrant 2, how would I figure out what theta is? Pi minus this value. And in quadrant 3, what would I do?
Pi plus
pi plus that value. So if I was to use my calculator, first of all, I want to make sure that I'm in radian mode. So I need to be in the correct mode. And then cos inverse 0.5. And then what I can do is I can go pi plus that answer. Oops. Pi plus that answer. And I get 4.19. And I can go second, enter, and then change the plus to a minus. Oh, no, that didn't work. Oh, because it took the answer from before. So then pi minus 1.047, and I get 2.09. I'm going to go back to B. I want to quickly try to show you how to do the exact values before you have to leave. We're going to trick the calculator into expressing things in radian mode. This goes through how you can use your calculator to do that. So we solved in before cos theta equals negative 0.5. We got a reference angle which is 60 degrees. Which gave us 120 and 240. We could do one of two things. We could convert 120 degrees into radian measure. When the question asks us to give this to them in exact radian measure, we could put everything in degrees and then convert back afterwards. Or what we could do is divide the reference angle by pi and convert the answer to a fraction. And then the fraction becomes a multiple of pi radians. And then we determine the rotation angle the same as we did before. So if I follow this, they're showing the computer screen at the same time. If I wanted to figure out cos theta equals negative 0.5, I know I have to be in quadrants 2 and 3. So the first thing that I do is I figure out what the reference angle is. So I go cos inverse, and I get this 1.047, etc., etc. If I take that answer and I divide it by pi, I now have a fraction. So that fraction is 1/3. Because I divided it by pi, I'm going to multiply it by pi to undo what I did. Because I can't just divide by pi, I've now changed the value. But if I divide by pi and then multiply by pi, it cancels out. Does that make sense, the canceling out? And then I've got my reference angle is pi over 3. So in the first quadrant, I would have pi minus pi over 3, which, think of pi as being 3 pi over 3, minus a pi over 3. Now I've got fractions with common denominators, so I can subtract the tops. 3 pi's minus 1 pi gives me 2 pi. And then the same thing can be done on the bottom. I rewrite pi as 3 pi over 3 and add pi over 3. And I get 4 pi over 3. And if I double check this and I went cos 2 pi over 3, I would get negative 0.5. If I went cos 4 pi over 3, I would get negative 0.5. If my reference angle was a pi over 6, what would I write this as? 6 pi over 6. Whatever your reference angle is, your fraction, write pi with the same fraction, with the same denominator. And then I can use my fraction rules. So that's how I can do those questions in a nutshell. Okay? I will write the assignment down, Evan, so that you can see it.
Okay.
And then I'll go back and do the examples, and I will upload this during the weekend.
What are you doing on Thursday and Friday?
Let me process. Thursday, tomorrow we won't be doing anything.
Okay.
Cotangent. So first of all, cotangent's a reciprocal trig function. What is it reciprocal to? Tangent. So that means tangent theta is going to be equal to what?
-4/5.
Negative 4/5. Okay. What quadrants is tan negative?
2 and 4.
2 and 4. But look at the restriction. Theta is between 0 and pi.
So it would just be 2.
Just 2. Good. Now I do my reference angle. Reference angle becomes tan inverse 4 divided by 5. I keep it positive. Make sure you're in radian mode. And let's express it to 3 decimal places.
0.675.
Good. So in quadrant 2, how would I calculate theta with the reference angle?
Pi minus the 0.675.
Yep. And what would that give me? What'd you get, Rachel?
2.466.
So to 2 decimal places would be 4,
2.47. 46. Yeah.
7?
Yeah.
Okay.
I was thinking 3 decimal places still.
Okay. Okay. So now let's look at doing these questions where I need to express the exact value. And you will be told the exact value of theta. So if you're told to the nearest tenth, you don't have to worry about anything, or nearest hundredth. You just use the radian value that comes up on your screen. But if you're told the exact value, then we need that conversion factor. So with sine theta equals 1/2, again, I start off from the same point. What quadrants is sine positive?
1 and 2.
1 and 2. Okay. Now I do my reference angle. So my reference angle is sine inverse 1 divided by 2. That's what I type into the calculator. Sine inverse 1 divided by 2. And I get this funky looking decimal. Take that decimal and divide it by pi. And now I've got this fraction. Or sorry, I've got this decimal that looks like it's repeating. Ignore the 7 there, it's just because it rounds the last digit. Change that to a fraction.
1/6.
1/6. So I end up getting 1/6 times pi, because I had to put the pi back in, which then gives me pi over 6. That's my reference angle. And if I was to double check that, if I go pi divided by 6, there's my 0.5235, etc., etc. Okay? So in quadrant 1, the reference angle is the same as the rotational angle, so I'm okay. How do I find the angle in quadrant 2? Pi minus pi over 6. And what would I change pi into so I can treat it as a fraction to subtract?
6 pi over 6.
So if I have 6 pi over 6 and I take pi over 6 away, what would I be left with?
5 pi over 6.
Good. Okay, so now we have secant theta. Secant's a reciprocal trig function. What is it reciprocal to?
1 over cos.
So the
Oh,
reciprocal is
reciprocal.
cos, and then it becomes 1 over root 2. And it would be negative.
Would Lane Schwartz and Mrs. Baum please make your way to the front office? Lane Schwartz and Mrs. Baum.
It's probably leave it at school.
Okay? Now I find my reference angle. So my reference angle is going to be cos inverse 1 divided by root 2, positive. So cos inverse 1 divided by root 2, and then divide that answer by pi, and I get 0.25, which as a fraction is 1/4. So my reference angle becomes 1/4 pi, which I then write as pi over 4. Oh, I forgot to say what quadrants I'm supposed to be in. 2 and 3, because cos is negative. So in quadrant 2, it's pi minus pi over 4, which would equal what?
3 pi over 4.
3 pi over 4. Because this I could rewrite as 4 pi over 4. And then in quadrant 3, it would be pi plus pi over 4, which would be
5 pi over 4.
5 pi over 4. Good. Okay. And then we have cosecant theta is undefined. So if cosecant theta is undefined, what did we say before?
Something divided by 0.
Something divided by 0. So that means that the reciprocal sine theta would then be equal to 0. And so I have to consider all 4 quadrants. So I find my reference angle. Sine inverse 0. And what do I get? 0. And this time it's 0 radians. Last time it was 0 degrees. So in the first quadrant, theta would be equal to 0 radians. What about the second quadrant?
Pi.
It's pi, because it would be pi minus 0 in the second quadrant. And in the third quadrant, how would I calculate it?
2 pi plus 0.
Okay. And then in the fourth quadrant, it would be 2 pi minus 0. So then theta could equal 0 pi or 2 pi. Any questions?